Hi, everybody. So just to preface the talk, I don't like to talk at people and say words. So at any point, please raise your hand and make this a dialogue rather than a monologue. But I'm just going to talk today about the KAZOO platform, which is an open source Erlang telephony platform that we've been building for the last 10 years at my company, 2600 Hertz. So who dis? My name is James Aimonetti. People in my company that have known me for 10 years still can't say it right, so I don't never expect anybody to get it right, so that's fine. I started with Erlang in 2006 from a blog article that Joe posted comparing Apache to Yaws, which Yaws is yet another web server. And he just kind of showed how the multi-core functionality of Erlang and Yaws allowed it to process concurrent requests way past when Apache fell over. And so at the time I was doing typical LAMP development, and so that was interesting to me, and so I kind of got into it through that avenue. Some of the things about me: I'm a developer, of course. I like to cook. I like to ferment things. I'm a dad to two boys, Miles and Owen, and I'm really into regenerative agriculture versus, so there's like industrial agriculture, and then there's sustainable, which I don't think is good enough. We need to be regenerative. So I've been doing a lot of projects around my house and town dealing with that type of work outside of code. Okay, so 2600 Hertz. Does anybody know the history of 2600 Hertz as it relates to telecom? Ish, okay. So back in the day when it was Ma Bell, 2600 Hertz was used for controlling the network. The freakers figured this out, and they started to make free phone calls. You've probably heard of Wozniak calling the Pope. They were able to do this by manipulating the tones that the telephone system used to make things happen. And of course, all the signaling was in-band and super secure because they never expected anybody to actually listen to the tones and figure all this out. Really cool history. Highly recommend you read about it. So why we chose 2600 Hertz as a company name is we want people, when the freakers figured out 2600 Hertz as a control mechanism, that gave ordinary mortals that didn't work for Ma Bell the ability to interact with the phone system in a way you couldn't before. Before that, you literally got a phone from them and plugged it in, and that was your interface. We hope to provide an interface into the phone system for most, for the masses, basically. So we started in 2010. We like to call ourselves the hippie commune of telecom because we like to give everything away, much to the chagrin of our business side of the company. But that's how it is. Most of us in the engineering side come from the open source world, and so that's just kind of our default mode. We saw a business opportunity of bridging the gap between the open source telephony projects that were out there and the commercial projects that were highly capital intensive, highly expensive to get started. Our whole goal is to become a telco in a box. You should be able to yum install KAZOO and you're a phone company, boom. And then our first project was Bluebox, which was a spinoff of FreePBX, if you have heard of that project. And that was a typical PHP LAMP stack that sat on top of FreeSWITCH and Asterisk for control. Our two technical co-founders, Darren and Carl, were both building telephony systems using Bluebox in their own lives, collaborating through Bluebox. That's how they met. And so they had a lot of similar shared frustration and experience of building these telephony systems. So one day they sat down and they were like, okay, if we could build like our ideal telephony platform, what would it look like? And so they I was really enjoying Robert's talk on how they kind of came to Erlang, because it's very similar to our journey, where they kind of ideated and put out these principles of what they wanted the system to look like. And then by chance, the Erlang factory was going on that same week that Carl was out here visiting Darren. And so they got onto it somehow, went to Erlang factory on a whim, and that's how Erlang was chosen. So anyway, they ideated. These were kind of the three main ways that people did telephony at the time. You kind of rolled your own duct tape on top of Asterisk or FreeSWITCH. You purchased a commercial offering like a BroadSoft or MetaSwitch, or you resold somebody else's switch So we were typically looking at the roll your own people because that's where Carl and Darren were coming from. So just very briefly, you would set up your FreeSWITCH or Asterisk server, and then you would learn what an SBC is, which at a very basic level is just a load balancer for phone calls. So you would set up an SBC in front and have multiple FreeSWITCH servers or Asterisk servers. And then your customers would start asking to be able to see their voicemail on a web UI, create their own call flows, et cetera. So now you have to build a web app. You have to put a database to propagate settings to all the FreeSWITCH servers. Or like one company we contracted with, they used rsync to propagate their configs. They wrote a flat file and then rsynced it to the FreeSWITCH servers. That was not redundant and robust. And then you have data center outages. So now you have to figure out how to do a multi-data center. So basically the idea was that you were getting further and further away from selling telephony services, which is probably what you wanted to be doing. And now you're a DB admin, now you're a web admin, now you have an IT staff. And on top of all of that, telecom's not exactly easy to do. So you have all of these telecom things, and doing it in a distributed system like this is not straightforward either. Like I literally had somebody ask me if they could, how we couldn't keep track of how many calls were active in a cluster. Couldn't we just update a counter? And I was like, well, you realize that there are calls elsewhere that we have to figure out. But anyway, they liked it conceptually. Sometimes people are like, oh yeah, you just update a counter and now you know. And like, well, you can't count things that are over, across a network connection that just got severed. So fun things like that that people don't realize. Basically, you've built a lot of work for yourself. So that's kind of where KAZOO comes in. We wanted it to be a platform where everybody could contribute to solve all of the common problems of building telephony platforms that didn't matter to your customers, right? Nobody cares about voicemail. Nobody pays for that, right? So why is everybody re-implementing a voicemail system? Why is everybody figuring out how BLF should work or how transfers should work when you have multiple FreeSWITCH servers? Why does everybody have to reinvent how to make sure a caller gets to the right server where a conference bridge has been started? Right? All of these technical details, everybody's solving them again and again and again for no reason other than we don't talk to each other, we don't share with each other. So we wanted to get past that and say, okay, let's build a platform with all the basic common stuff solved, and then expose APIs so that you can build your differentiators on top. All right, so that's the problem that we are trying to attack. So KAZOO today, we've had 119 people contribute to the project, about 14 of which are actual Erlang engineers that have been paid by 2600 Hertz. All of the others were documentation updates or open source contributors. We have a couple here in the audience. We have GitHub stars and forks, but I have yet to figure out how to pay for college or buy groceries with those, so whatever. And then we've accepted pull requests from every continent at this point except Antarctica. So if anybody's planning on taking a boat down there and wants to open one just so we can check that off, that'd be cool. And currently in the open source project, we're approaching 300,000 lines of Erlang code, plus or minus 10,000 C and Python and other associated stuff. We're probably closer to 500,000 total because we do have some private closed source modules that we maintain. But it's a fairly big project and it's evolved over 10 years. So we'll talk about some of the challenges of that. If you haven't seen it before, this is kind of our basic high-level architecture. So each of these black verticals represents a data center. And then within each data center, you would have multiple instances of your SBCs, multiple instances of your media servers, and then multiple instances of KAZOO running so that you have no single points of failure. And then we do lots of fun stuff between data centers to minimize traffic, but still be able to make things work. And then on this side, you have all your different client devices that you typically would integrate with. And then on the right side would be your service providers, like your upstream carriers, your emergency services, things like that. And so the whole goal is that all of this infrastructure to manage a multi-data center telecom platform is there in KAZOO for you, so you don't have to reinvent any of this. Any questions so far? I'm going to start calling on people. How about that? Just kidding. All right, so in 2010, when I joined the company, I knew nothing about Erlang, literally nothing. Or not Erlang, telecom. I knew all about Erlang. That's why they hired me. So Darren and Carl knew they wanted to do Erlang, but they didn't know it. Carl started playing around with it for fun, and then I found the job posting. So anyway, our skill sets dovetailed nicely. I had been doing Erlang for about 4 years at that point, and they had been doing telecom for much longer, especially Darren. So they started to teach me telecom, which if you haven't been in telecom before, get ready for acronym overload. It's amazing. The project was originally called Whistle, and so we interacted with FreeSWITCH, which was the primary media server, doing the telephony stuff, initially over a text-based socket, both for sending commands in and receiving events out of, which, as you can imagine, is not the greatest experience. Then we realized that there was a C-node library called Mod Erlang Event that had been built already, so we started to experiment with this. We started with Rebar 2 because we didn't know any better. And then each app that we built was bespoke, so we didn't have sort of this common framework to build on yet, which led to a lot of interesting experiments, some of which still live to today. Trunk store. So a little bit about Mono Erlang Event. It's, as I said, a C node, so we were able to talk to FreeSWITCH as if it was another Erlang node, which vastly simplified our code. It was built as part of the OpenACD project, which if you know Andrew Thompson, or Vagabond, on IRC. He was the one working on that. This is also where Gen SMTP spawned from. So it helped us hit the ground and get running. It was great. One of the funny, quirky parts is that it officially only supported a single VM connecting to the FreeSWITCH server, but because of a bug in his C code, we were actually able to connect multiple VMs, but it wasn't like an officially supported thing. It kind of worked by accident. And when we saw him at a conference and told him about it, he was like, oh, that shouldn't work. So that was pretty funny. The other shortcoming, what we later learned about a shortcoming, is that everything was done over distributed Erlang, which if you know any of the shortcomings of that with like head-of-line blocking and stuff, this will come up later in our journey. But as far as like getting us started, making it easy, it was a great entry point into manipulating FreeSWITCH efficiently. So I joined in June. In August, the FreeSWITCH team puts on a conference called KlueCon. It's a really great conference if you want to do telecom-y stuff. Definitely worth going to. And I literally was back here in San Francisco on the Erlang virtual machine as Darren did the demo with people calling in, ready to restart things. And spoiler alert, it went okay. And I didn't have to do much. Some of the mistakes we made early on was signing a 24-hour intensive care facility. That was a big mistake because suddenly any sort of maintenance window went out the window, as well as the platform wasn't always the most stable. So we were basically on call 24/7. It was a trying time. But the other big customer that we signed was a company in New York City that did short and midterm rentals for international travelers. And what they would do is purchase phone numbers in the countries where people were coming from so that friends and family could call a local number and reach the property where the person was staying. And then they also tied it to a cell phone so if I traveled to New York City, they would give me a cell phone to use that my parents or whomever could call me on using a local number to the country, but it would get bridged to the cell phone here in the US. So that was pretty cool, but it made us focus from day one on the international telephony community. Most of the systems that we were dealing with or sort of competing with were homegrown in the US, and so they were very US focused, and any attempts at internationalization were an afterthought and a bolted on thing that usually worked as well as you would expect, which was not. The four major components that we built on top of, I talked about FreeSWITCH. Kamailio is a very popular SIP library, or SIP software. They don't do any media handling like FreeSWITCH does, so they don't do audio transcoding or anything like that. So that's what we use at the SBC layer, FreeSWITCH. And then internally we use RabbitMQ and CouchDB. We do not use distributed Erlang for the inter-node communication because people needed to be able to replace pieces of the infrastructure with things written in other languages. So RabbitMQ was a very nice way to do that. And then Couch, because telecom engineers are smart in a lot of ways, but programming, most of them do like PHP, and so we kept it simple and kept it JSON, and so CouchDB was a natural choice because it was just a JSON document store. And there's a whole lot of other reasons why we didn't go with Postgres or MySQL or something else that I won't get into, but suffice it to say it was easy, the operations story is very nice, etc. Okay, any questions so far? So that's kind of the beginning. So I'm starting to learn my ears are melting with acronyms, but we're starting to make things happen. So like I said, in 2010, everything was bespoke. We were still learning how to interact with Rabbit properly, et cetera, et cetera. Finally, in 2011, we were like, okay, we need to standardize. So we wrote our first behavior called GenListener. This standardized how KAZOO talked to Rabbit and how applications consumed events from the message bus. It had a very nice effect of removing all AMQP-specific bits from the business logic applications. So that was a huge win for it. And then just GenListener is basically GenServer with AMQP-specific bits in it. So it's made it a very nice development experience where we can take people that don't know AMQP and get them writing applications, but that they don't have to know how channels work and how to set up a queue and what bindings are and topic exchanges and all that AMQP-specific stuff. So one of the eggs in our face as dummy noobs, we committed beams to the repo because we had customers that did not allow us to access the public internet. So we had to ship them something that had all the beams in it. So we were just like, well, let's just commit the beams to the repo and ship them a particular commit hash. We didn't have releases because Relics didn't exist yet to make it easy. So yeah, we did that. Not proud, but also it was a good learning experience. But it was for reasons, not just because we were dumb. We also got a fun letter from a company called WhistlePhone, which developed a iOS soft phone. It's called WhistlePhone, and they felt like Whistle was too confusing for their consumers, and they were suing us unless we changed the name. So we're like, well, we're not VC funded, we don't have a war chest, so I guess we'll change the name. So that's how KAZOO came to be, and we tagged it as 2.0. The focus up to this point had been features, 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 because you would show people what you supported and then be like, well, your competitor has 50 checkboxes and you only have 7. I was like, well, how many of those 50 do you use? Well, 2, but I might want to use those other 48. So we're like, oh God, okay. So there was a lot of cowboy coding. There was a lot of people wouldn't even talk to us until we had those 50 checkboxes. So while we tried to maintain discipline, sometimes we might have opted for the 80% good solution, and then when people complained, we would fix the last 20%. You know, give and take, give and take. I'm just being real. So in KAZOO 3.0, we released that, and then the project had matured. A lot of the stability issues that we had been having up to that point were mitigated. I won't say solved because they're never solved. We reached feature parity. Oh good, I did spell that right. We reached feature parity with the majority of our competitors, so now, and we had been around for a couple of years. Like we literally had people come up to conventions and be like, oh, you guys are back. Well, that's great. We didn't think you would survive. Now we can talk to you. Okay, that's cool. And then the other big change was that we finally hit the breaking point with mod Erlang event where it wasn't working for us at the scale, at the small scale that we were at that point. So we wrote mod KAZOO. The big changes were that we had first-class support for multiple connections. And then we started putting all the events coming out of FreeSWITCH over TCP sockets that KAZOO would ask to set up. And that way only control events were going from KAZOO into FreeSWITCH. Because we were getting like a lot of head-of-line blocking and stuff like that. Yes? So mod Erlang event is C node code in FreeSWITCH. that we originally leveraged. And then mod KAZOO is the replacement C node code that we wrote specifically for our use case. So mod Erlang event is still great. It's still used. It just didn't fit our use case anymore. So that was a huge change for us. And immediately a ton of stability issues evaporated. So in CouchDB, if you're not familiar, you create a database and then you store JSON documents in it. And then you can create things that are called views, which basically for every document, you can create a secondary index across all of your documents. What was happening is with busy accounts, all of the configuration data, like for your devices and users, was being stored in the account database, as well as all of your CDRs, all of your faxes, everything related to the account. What would happen is the view indexes are only updated on demand, so only when the view is accessed, which means if you have a really busy account and you have 10,000 CDRs come through before somebody loads the UI to fetch the listing of users, the view now has to go and process all 10,000 of those CDRs, which it's just going to ignore, but it's still time. And so API requests would time out because the view re-indexing was taking too long, yada, yada, yada. So we moved architecturally to a system where the account database now stores configuration about the account, and then we have what we call MODBs, or month-only databases, where things that are tied to a point in time are stored, like CDRs. CDRs are at the end of every call. CDR stands for call detail record. It just tells you who called who for how long, and then lots of other information about the call for billing purposes and things like that. The other nice thing about moving to the MODB architecture is people could archive them after, say, keep 6 months active in the database cluster, and then you could archive to cold storage after that. Also in 2014, my first son was born. So I wasn't kidding. We were working 16, 18-hour days, 6 days a week. It was a lot of fun. I'm not going to lie. We were having a good time. It wasn't like a death march type situation. We were doing it because we were passionate about it and having a good time doing it. I'm very thankful that Miles came when he did because, A, he came on the 4th of July, which is just pretty cool. But he also in some ways, forced the company to realize that we're not all going to be 20-somethings with no family responsibilities forever. And so we started to have more work-life balance, which was nice. But we were also growing to the point where we could start to offload. I didn't have to be on 24/7 support of the production cluster anymore, which was a big win. So apart from just being awesome to become a dad, it was also nice because work started to become a little more reasonable. In 2015, so at this point, the project is getting pretty big. We got a lot of applications. We got a lot of core libraries, a lot of Erlang code that we're managing. Rebar 2 is really starting to show its slowness. So we ditched it and built our own makefile and have like straight calls to ErlC. And we do lots of other stuff too. We also do direct calls to Dialyzer and Xref and other utilities like that. So everything is managed by the makefile system. We've looked at doing a Rebar 3 conversion. It doesn't work for us yet. And granted, we haven't spent that much time trying to do it, but the times we have done it, it's proven. We have so much tooling that's very specific to our use case now that I don't think we'll be able to convert to it, but maybe. We'll see. But anyway, we have things like where we only dialyze the files that changed in a particular pull request rather than the entire project because it's huge and takes forever. So we have targets for dialyzing just the changed files. And then I added one that does a hard dialyze where it'll take the changed files, figure out all of the modules that are called from those changed files, and then dialyze them all in a big group. So you can make sure that any function calls that you're calling outside of your change set, that you're conforming to the specs and things like that. So there's like tooling like that where I don't know how we would do that in Rebar 3, and I don't know or care to make the time to figure it out because it works. So we'll see. I mean, I'm not opposed to it philosophically. I just don't think there's a lot of business value to justify the work, if that makes sense. All right. So 2016, we're starting to see an uptick in traffic on the different clusters that we manage. One of the big ones was a cache serialization. So we have some caching between Couch and KAZOO, basically a nets table with some LRU properties and things like that. Initially, we set it up with, it's got to be protected, and we're going to serialize through a gen server to make sure everything's nice and orderly. That was starting to not be a good situation for us anymore, so we moved it to a public table. It's all still behind a KZ cache module, so the fact that it's implemented as a nets table is hidden from the callers and things like that. But we were able to parallelize the reads and writes and made that disappear. Federation appears. So in that in the multi-data center picture, before we kind of just like connected everybody in a big mesh, and there was a lot of inter-node traffic that was kind of unnecessary. Federation allowed us to pare back how much inter-data center communication there is, and so that's been really nice. And then the other big one is that the documentation started in earnest. Another egg in the face kind of situation. We didn't document as well as we could have or should have, mostly because we were just going so fast that the documentation was stale, a week later. So it was like, why bother? But I also know that we're developers, we're lazy. We don't like to have to do that stuff. And even code annotations I didn't want to do because they all bit rot. So I was like, well, what's the source of truth? It is the code. So I wrote an AST parser that takes the, because we had standardized API endpoint modules, I was able to read the AST and get, extract data from that I could generate what I called a reference doc, which was basically like, here's a machine generated version of the API documentation. And then we have sort of the human augmented version that's actually what's on our documentation sites. So what it did initially was there were a whole bunch of, since it's kind of a REST-y API, the URL defines things, there were a bunch of paths that were technically valid that led to nonsense results. So we were able to, this tool was able to show us all this nonsense that was technically callable. So we were able to tighten up our API so that we weren't exposing things that we didn't mean to or that didn't make sense. But then it also allowed us, when somebody added something new or made a change to an API endpoint, it would be reflected in this machine-generated reference doc. And so then if they did not also update the human augmented version, the reviewer could now yell at them and say, hey, there's a documentation update that you forgot to commit. Why don't you go ahead and document it? So that was a very nice thing from the review side of giving us tooling to say, something has changed, you need to talk to your developer about it. And then of course that's grown, so there's a lot more stuff there where we use the AST to inform the documentation, to inform the schemas that we use to validate data, things like that. 2016 continues. We have storage plans appear. So in Couch, you can store binary data. It's not the greatest use case for it. So we added storage plans. So now customers can have their voicemails stored to their S3 buckets or to a custom HTTP server, what have you, whatever you want to do. And so that's been a huge win for getting those binary blobs out of Couch and into a customer-controlled area, which is really great for compliance and things like that. And of course, the highlight of 2016 is that my second son was born. And not to be outdone by his Independence Day brother, he was born on Christmas Day, which, you played yourself, buddy, because now we're like debating, do we do like half birthdays instead? Or fortunately, he's still too young to really realize that he's being upstaged by a holiday, but yeah, that's been a fun one. So KAZOO 2017, we hit 4.0. So now we're at web scale. We've got clusters that are bordering on 1 million devices. Things are really humming along. And we're starting to hit new scalability concerns. One of the first ones was a problem known as cache stampeding. So we had a customer site. So SIP typically is done over UDP, so it's sessionless. This particular customer, for whatever reason, had to do TCP. And So they had a site with like 400 phones on it. They had a network flap. All those TCP sessions go down. As soon as the network comes back up, all those phones register at the same time. And the way KAZOO works, we fetch the account doc with account configuration, and then the user docs, and then the device docs. And we kind of do this merge down to figure out what the actual settings for that device are going to be. So what happened is the account doc was not in the cache. We have 400 plus requests coming in all concurrently. So now all 400 of those check the cache. It's not there. So then they all send 400 requests to the database. And it started to overwhelm the database with this stampede of stuff. So we wrote some stampede mitigation code so that the first request that goes back to the database will basically put a block in the cache so that every additional request, when it checks the cache, will see that it's stampede mitigated. And so they'll block in KAZOO instead of sending an additional request to Couch for the same data. And then once the response from Couch comes back in, all of those that are blocking on the stampede will get their responses at the same time as the initial request that generated the database lookup. Does that make sense? So that was a fun one to try and figure out how to do. But it's been super beneficial. So yeah. So now we're looking at 5.0. The push right now is more and more self-service, so we want customers to be able to see. We've always tried to expose as much information as possible, even though it overwhelms people or they don't understand, what like lose race means when a call hangs up with that cause. They're like, what race? Who was racing? So it's things like that where we need to get better about educating when things are bad errors versus when things are benign errors. So you get fun stuff like that, or then you get really cryptic things like mandatory, i.e. missing. Does anybody know what that means? Yeah, exactly. So you get weird stuff in SIP that leaks out into the consumer-facing stuff, and then you've got to figure out how to explain it to them. So we're building more self-service features where you get access to that data, but you also get access to help to tell you what it means. Like mandatory, i.e. missing, is almost always a network thing. A firewall on the client side. We have a fair amount of dependencies. It's no Node.js project, but we're evaluating a lot of them, trying to get rid of the ones that we can, bring in-house some of the ones that aren't maintained anymore. I'm trying to add Elixir to the tool chain. It obviously didn't exist when we got started. I have nothing against it. I don't plan to use it, but I also don't want to restrict people that do want to use it to contribute to the project. So I'm working on adding that to the tool chain. More cluster-wide tooling to allow people to inspect what the cluster is doing or to simulate how something happens to better debug. Lots of technical debt remediation. I was joking about an app called Chunk Store, which is one of the first ones that I wrote way back in the day. The biggest problem with Chunk Store is that we partnered with another developer who was a PHP developer, and he kind of drove the design. And made a lot of terrible decisions, but he had telecom experience and I didn't, so I kind of deferred to him because I didn't know any better, because this was 2010. I was just learning what VoIP even stood for. The other problem is that we had a customer almost immediately start using it, and so we couldn't just throw it away and start over. So if you ever want to look at what technical debt looks like, look at the Chunk Store code, because it's very begrudgingly been brought along, but it still does a lot of weird, non-idiomatic KAZOO things. So that's been fun, but we plan to finally get rid of it for good. And then lastly, improving the auto-discovery and auto-config of KAZOO. Back in the very beginning, there were 30 flat files that you had to edit to get things to work properly. Now there's only one, and most of the config lives in the database. Where we're moving now is for things to start auto-discovering themselves when they connect to Rabbit. Like right now, when Ecom Manager, which is the layer that talks to FreeSWITch, connects, it publishes something into AMQP. Kamailio receives that payload, and it can update its dispatcher list to know that a new FreeSWITch server is available to dispatch calls to. So you can start to do fun things like that with the auto-scaling and whatnot. With the goal being that we can do a yum install KAZOO, and it just auto-detects everything and starts working. The other big thing is we have been a mono repo up to this point. Over time, applications get replaced, or we provide a commercial version, and so then an application becomes community supported or Voxter supported, as the case may be. But it's confusing to our specific customers because they say, oh, I want to use this app, and we tell them that it's community supported and they can't get support for it from us. And so that's a confusing part of the business process right now. So the Great Breakening, part of that is differentiating what's community supported versus covered by a 2600 Hertz support plan. So we'll be moving to single repos for every app. But the other nice thing that this is going to do is allow the app exchange to happen, where third-party developers can create their own KAZOO apps, put them into the marketplace for anybody that runs KAZOO to purchase and run and get put on their cluster. And what this is forcing us to do, and mostly Sean, is to build the tooling out to take the crossbar application, which is our API server, and put it through the tool chain and build an RPM that is now installable. So what that's forcing us to do is now third-party developers are going to go through the same tool chain, and our private apps are going through the same tool chain. So we're all going to benefit from all of this work, even though some people are kind of freaking out that, oh, 2600 Hertz is leaving open source, and that's not the case at all. But it's a precursor to allowing more people to participate in the development of applications that run in a KAZOO cluster. And so long-term, yum install KAZOO is the goal. We're almost there. Yes. Okay, so that's kind of the timeline of the last 10 years. Are there any questions so far? Okay. Then I'll just talk a little bit about Erlang engineering, the way we do it, and then a couple war stories, and then we'll be done. So from day one, I said we wanted the platform to be runnable in Europe, in South America, in Asia. So we tried as best as we could, even though we were all Americans at the time, to make it extensible to wherever in the world. The community, for whatever reason, we had a lot of Russians, and where is it? Well, anyway, we had a lot of Russians, first and foremost, who got involved in the project very early on and helped us make sure that things were working for international use cases, as well as submitting code and regexes and things like that that were relevant. It also is what kind of attracted some of our employees that continued to help that. Some of the things that it's done for the code is that we've been we try to be good about using full variable names instead of shortened things. Obviously, if you're like in a tight loop or something where it makes sense to use single letter variables, fine. But anything that's being passed around, we try to opt for account ID instead of ACCT ID or something like that. I wrote a very basic spell checker. I took like the top 500 misspellings, added all of Carl's misspellings. So if you don't know Carl, he's our CTO. His parents were at different times magazine editors, English teachers, and yet he is the worst speller in the world, to the point where we have a long-running joke. When he wrote the time of day routing, so what to do, like route 9 to 5 to the secretary, otherwise route to a voicemail box, right? A very basic one. When he coded it up, he very consistently spelled Wednesday, W-E-N-S-D-A-Y. He spelt it phonetically through the entire module, though, to his credit. And the best part about it is we had a bunch of French front-end developers who didn't know any better, so they coded the front end up, spelling it phonetically as well. So we still have code in there that's Wednesday phonetically and Wednesday properly spelled. So I have a lot of spell checking, not only for Carl, but also like just to kind of help our international community with some basic common misspellings and automatically converting them. And then one of the other ones that I've really liked is using, I don't typically like getter, setter modules, but we've been doing that for our JSON objects so that, because it's all too easy with a binary to transpose a letter And when you're reviewing it, just to kind of gloss over, your mind auto-corrects it. And so, we've had bugs where the default action kept happening because the key didn't exist. But then we'd look at the object and we'd be like, the key is right there. Why isn't it doing this other functionality? And then we'd go to the code and you'd look at it and your mind would auto-correct it. And you're like, it looks like it should work. Well, I'm going crazy. But Dialyzer and XREF and whatnot, the tooling couldn't fix this for us because to them, the binary is opaque. So by moving to this, not only do we get context on what the object is the JSON object is, but we also get the nice compiler help to make sure that people are spelling things properly and that we're accessing the field in the JSON object that we think we are. So those are a couple of the things with having a multilingual team and community that we found. And then we have a couple libraries in our core library for dealing with international prompts. I kind of knew it, but I always knew that there was like French, and then there's Canadian French. And we had some French-Canadian developers who submitted code with French-Canadian prompts. And I asked the French guys in our office to review the prompts, and they're like, these sound like trash. And I was like, what do you mean? He's like, this is not how we would say it in Paris. And I was like, okay, so should we go back to him? So then we went back to him, and they're like, actually, according to the Canadian rules on French-Canadian, it's exactly right, and the French is wrong. The French don't even speak French right. And it was this whole thing. And I was like, okay, you guys figure it out. And I'm sure Spanish has similar situations with Castilian and whatnot. But it was just one of those things where I never expected this to be a contentious issue of the French translation. And we actually did have it because one of our guys in Miami submitted Spanish prompts, but they used a Colombian, I forget, somebody in South America to do the translation. And then we had a whole bunch of people from other Spanish-speaking countries being like, this is not how we would say it. And I was like, I don't know any better. Like, submit a pull request. What do I know? Anyway, then the KAZOO numbers is for handling number plan. Fortunately, we have E164, which is sort of an international numbering plan system that we leverage. So that's been really nice. So even though by default, the default examples are all American numbering plan type stuff, we have a lot of contributed examples of how you would configure it for the Netherlands, for instance. So people can take it and modify it to suit their particular country or countries that they support. So that's been really cool. I didn't know how to make a good Venn diagram, but basically you have telecom people and you have Erlang people, at least in the US. I know in Sweden it would be different. But there's like one person that has both skills. So hiring has been challenging as far as we can't just put out a job rec saying, hey, it'd be really great if you knew Erlang and SIP, because those people don't really exist. So at this point, our hiring process is, does this sound cool? Do you want to learn Erlang? Do you want to learn telecom? We'll teach you. And if people are still interested after we kind of give them the whole architecture breakdown and how everything works, if they haven't run away yet, then we basically hire them. And then it's kind of a, they tend to self-select out at that point. They're just like, okay, this might be a little more than I wanted to chew on. So that's been fun, but it's been really fun to get into that mentoring, teaching aspect of it all. Both of my parents were teachers. I always figured if I wasn't a programmer, I'd be a teacher. So it's nice to have that part of, to be able to do that part within the job. And I feel like too many companies don't invest in their employees that way. So it's nice to be able to do that. But because of our interesting little cross-section of technologies, we've found people in very random places. Like for instance, Sean basically came through a Reddit comment thread where our marketing guy at the time, and he conversed, and then here he is now. One of our other developers, so we do mostly a yearly conference called KazooCon, where people come together. One of our attendees from the Netherlands was staying at a hostel where Hassam happened to be staying too. They got to chatting one night and found out that Hassam knew a little Erlang. And so Job was like, oh, you got to go talk to these guys. They do Erlang. And so Hassam came and he was like, well, I don't really know any telecom. He was like, you don't have to. We'll teach you. So we hired him, and he's been amazing. But it's like, who expected to find a next hire in a hostel? So yeah, it's just like weird things. And then there was this weird, so all those French guys that I was telling you about, there's a school actually not too far from here, like 2 blocks from here. It doesn't exist anymore. But they would come over from France to do a master's at this school, and part of their coursework was that they had to get a 6-month and then a 9-month internship with a US company. And so I forget how Darren got invited to give a talk there, and then we basically were like, does anybody want an internship? So that first, like in 2011, we got a batch of 7, and then I think we hired on 3 of them after that, and then we got a second round out of that. So just like these random French guys were suddenly working for us, and I was able to convert one of them to the Erlang team. So that was fun. And then Pierre Fennel, if you know him, he reached out on the Erlang mailing list, was like, hey, I want to come to the US and work. And so I reached out to him privately, and we were able to make it work for him to come over and work with us. And I thought we would have him for maybe a year. I mean, he's kind of like he's got big plans. But he actually ended up working with us for like 3 or 4 years. So it was really cool. And then the best one was Luis, who's our other senior top engineer. He was running KAZOO in Portugal, doing his own telecom company, and was submitting a lot of really great pull requests. We kept being like, man, I wish we could hire him, So then one day he had a really bad experience with a customer, and he was venting to me on IRC about it. So I was like, Darren. So Darren talked to him. He's like, hey, how would you like to work on KAZOO? He's like, I would love nothing more than to work on KAZOO and not deal with customers. And so that's how Luis came to the project. So it's just like, I tell people, like, if you look at on paper, our engineering team, you'd be like, I mean, nobody went to a top tier school. Nobody has like bona fides or anything like that. And yet here we are 10 years later. There's one company that I know of that tried to build something similar to KAZOO. They had 10 engineers, $3 million over 3 years, and they just threw it all away at that point because they couldn't get it to work. And we basically did it with 2-3 people in the first couple of years, and now we're at like 7 or 8. So I think part of that is the staff has been amazing and has really embraced learning and working together. But I think Erlang is the force multiplier in all of that. I don't think we do it if we had done this in Java. That's my little spiel. So part of that is that VoIP infrastructure is hard, so we've always tried to be welcoming of people. We don't make fun of you for not knowing what a particular acronym means, or that you didn't know some basic Linux command. We try not to have an ego or think too highly of ourselves, which I think fits in with this, what I always see from Robert and Joe, and the sort of the Swedish mindset. We try not to blame people when bugs get found. We'll get blamed to figure out who did it so that we can go talk to them about why it's a certain way, because maybe we don't understand. But it's never like, I've never been chastised because I introduced a bug that caused a customer to have an outage. It's just not what we're going to do, because there are so many steps from the point that code got written to being deployed on production that everybody failed. And so we're not going to blame any particular person. We're all going to learn from it. We're going to improve process. We're going to improve testing, whatever it might be. So I feel like that's been a huge boon. You are not your code. We try not to balkanize and let people get too narrowly focused. Basically, Mark is the only guy that's balkanized at that point, but that's because he has a specific skill set on building call center stuff. But in the broader KAZOO ecosystem, nobody owns Fax, nobody owns the API server. Everybody works on it together. And then I tell people, as soon as we hire somebody, the first thing I tell them when I start training them is, I've been here for 10 years. I have been in the weeds for so long. I don't know what doesn't make sense anymore, because I've basically either written it or been a part of reviewing it. So like a lot of the warts, I don't even see them anymore. So I love when we get new people in the project, because they see things and they're like, this is kind of weird, right? And I was like, oh yeah, I guess that is kind of weird. Or it'll be like old code that hasn't been updated to the newer way that we do things. And they'll be like, why didn't you use this library? I was like, oh yeah, because it didn't exist yet when I wrote that. So okay, let's update it. So I feel like that sets the tone from day one that even if you've never looked at Erlang code, you can still contribute, because as I'm saying things to you, the things that don't make sense means we haven't documented it well, or there's been some failing on our side. It's not that you're dumb or can't understand this. It's that something about the project is not allowing you to comprehend it, and we can do better. And so I feel like it's a really good attitude to have. And so my favorite comic on this is the XKCD comic, where rather than making fun of somebody for not knowing something you think is trivial or should be known, getting excited to share that new thing. You're one of the lucky 10,000 today, because statistically, like, there's no way we can all know everything. And so I feel like this attitude within the team is what allows us to succeed in a lot of ways. But more practically, the other part of it is we do have pretty good tooling, even though most of it's homegrown and not generally applicable. We do a lot of dialyzer work. We have a consistent formatting tool that we use based on Emacs, of course. Just kidding. I was talking about the AST parsers for generating the documentation. That's been a huge boon for CI so that people can, am I at time? Oh, okay. All right, I'll just go really fast. So we've got eUnit proper testing. I talked about that stuff. Documentation. The documentation lives in the repo, so it's really close to where the devs work. Every commit to master that has a documentation change, the doc site gets rebuilt, so it's always up to date. AST parsers, different docs for different audiences. I'll just do one more story. We had a customer that does a lot of hotels. They had a phone at the pool that auto dials 911. They were power washing the pool. It caused the phone to short out and dial 911, but they hadn't configured an address, which in the US is a $70 fine for every call, and about every 5 seconds it would place a call. So by the time they figured it out and cut it off, it had dialed about 1,000 times. We got a $75,000 bill for their pool phone that was generously reduced to $20K. So these are things that you would never think would happen. freeconferencecall.com, I won't talk about what traffic pumping is, but basically my wife's company at the time had a merger, and so everybody called into a freeconferencecall.com number, which every person that dialed in we were being charged 22 cents a minute for it, but we only charged a penny a minute or whatever it was at the time. And they were not a profitable client to begin with, and it really got bad. And then we have people that set up ring groups with 100 plus endpoints in it, which blew out our network framing on our packets to FreeSWITch, so we had to fix that. So those were just like 3 of the random bizarre things that customers have done to us. Does this sound fun? We're always informally hiring, if not explicitly.
Thank you, James. We'll probably have to wrap it up now.